Okay, hello Bio, this is Mr. B, and we're going to finish up Chapter 17 with our last section here. It'll be broken up into two parts, and this section is Patterns of Evolution. So we've talked about what evolution is, and now we're going to talk about different ways that evolution can actually occur. So there's different methods, different driving forces behind the different types of evolution. And so to start today, we're going to look at what is called macroevolution. So macro is the opposite of micro. We all know micro means very small, so macro, the opposite of that, it means very large. So macroevolution refers to large-scale evolutionary patterns and processes that occur over long periods of time. So macroevolution, again, the big key word here being it's a large-scale evolutionary pattern. And there's several different things that are patterns that make up macroevolution. So there's 6 of them, actually. And so there's 6 important topics in macroevolution are extinction, adaptive radiation, convergent evolution, coevolution, punctuated equilibrium, and changes in developmental genes. So all 6 of these we're going to get into, and we're going to talk about how they're important to the concept of macroevolution, which again is just a large-scale evolutionary patterns and processes that cause things to change. So first thing we're going to look at is how in the heck does extinction play a role in evolution, because you'd think it'd almost be the opposite. So in extinction, more than 99% of all species that have ever lived are now extinct. So that's a pretty incredible number, that more than 99% of all species that have ever walked the earth are now extinct today. And so in the past, most researchers have looked for a single major cause for each mass extinction. However, there's actually one giant crater in Mexico that they think could be one of the major causes of the mass extinction of the dinosaurs. However, they think that mostly now that they think that mass extinctions were caused by several factors. So they don't think now that there was just one major catastrophic event that occurred that caused everything to die. We now think that it's more of there was multiple things going on that caused these extinctions to occur. And so mass extinctions, they can't be all bad because there's still plenty of life on Earth today. So we're going to look at how mass extinctions have had, what impact they have had on the history of life. So mass extinctions have provided ecological opportunities for organisms that survive. So a good example for this one would be that if the dinosaurs never died off, mammals would have never had a chance to survive and develop, and we might not be here today. So since all the dinosaurs died at the end of the Cretaceous period, which probably seemed catastrophic at the time, it provided opportunities for other organisms to grow and develop and kind of take their turn on the Earth, I guess you would say. And so then it also resulted in bursts of evolution that produced many new species. So since there is so much different habitats to be occupied, one species could give rise to multiple other species, which could give rise to multiple other species, and then we could just have huge bursts of a lot of new organisms on the Earth today. So extinctions seem bad, however they provide opportunities for other organisms, and they lead to a lot of large-scale changes. And one of these changes is called adaptive radiation. So this is a very important word you're going to need to know. And adaptive radiation is the process by which a single species or a small group of species evolves into several different forms that live in different ways. And we have already discussed one huge example of adaptive radiation in the past chapters, and that is Darwin's finches. So more than a dozen species, which I think we said he found 13, evolved from one single species of finch. So we already have a great example of adaptive radiation. You've already learned about this before. So Darwin and his finches are a great example of adaptive radiation again, starting with one, and it evolves into several different forms. And then adaptive radiation can also occur on a much larger scale. It doesn't just it can be more than just giving rise to 13 different finches. And the disappearance of dinosaurs, then it resulted in the adaptive radiation of mammals. So since the dinosaurs were no longer living everywhere on the Earth, eating all the food, taking all the resources, the mammals just exploded. So they didn't give rise to just 13 different species of mammals. I think today we have over 3,500 species of mammals living just today. So you can imagine back then we probably had even more, considering the fact that 99% of our species have died out. And so our example here would be that we have one group of our ancestral mammals down here, and it gave rise to all these different groups up here. And once we take Bio 2, we'll take a look at what these all long, complicated words actually mean. But for our sake, all I want you to know for this picture is that it shows us that one ancestor group gave rise to all of those different different groups that are still alive today. So that is it for our first part of this section. Let me know if you have any questions.